Okay, my dear friends, right now we are solving the paper 4 variant 2 May June 2023, and the question in front of us is regarding pressures concept. Question number 3. Figure 3.1 shows a person moving across an ice covered pond to reach a ball on the ice. To reach a ball on the ice. So explain why this way of moving across the ice is safer than walking. Use your understanding of pressure in your answer. We will use our understanding of pressure, but before that, just let me share with you something. We know that pressure is equal to force per unit area. Now for this person, force means the weight of the body is constant, is same. Either the person is moving across the ice this way, or he is standing and moving on his both feet. Whatever the way, the uh, weight of the body is constant. Like anybody is sleeping on his bed, he is standing on the bed, he is standing on the floor, he is standing on one foot. In any case, the weight of the body is constant. So the weight of this person is also constant, but the area of contact of the person can be changed. In this way, the area of contact of this person with the floor is more, so force is spreading over a larger area, and pressure is inversely proportional to area. So when the area will be more, so pressure exerted on the ice will be less, and there are less chances of breaking the ice, so he can safely reach to the football and carry it and take it. So that is the basic concept, and I'm going to write this one all right now in the answer. So force weight is spreading over a large area, and then you can also say pressure is equal to force per unit area, and this implies that pressure is inversely proportional to area when the force is kept what? Constant. So in this way of moving, in this way of moving across the ice, pressure on the ice is less, and it is less likely for the ice to break or crack. So the person can reach easily to the football and carry it, take it. Now next is, my dear friends, first time this sort of question is there. Otherwise we are talking about total pressure, pressure of the atmosphere and the pressure of the liquid, but here is the pressure of the solid plus the pressure of the liquid. Anyhow, figure shows the side view of a pond with a layer of ice floating freely on the water. So up there is a layer of ice and below there is water, and this is always there on even the frozen lakes, frozen rivers, frozen oceans. So up there is a layer of ice and below there is water, in general at 4 degrees Celsius. The water below is in general at 4 degrees Celsius, even in really severe cold weather. So that is what much suitable for the aquatic life. So aquatic life is surviving in the cold weathers just within that water below the layer of ice at 4 degrees Celsius. Not layer of ice at 4, mean water at 4 degrees Celsius in general. That is all happening because of the irregular expansion of water, but that is not the part of our syllabus, so we will not be discussing it at all. So now the data given, see, this is the area of cross section, here is the mass of ice, this is the density of water, and this is the depth below the ice. All the data is very clearly mentioned. Now calculate the pressure at point X due to ice and due to water. So pressure will be at X. It will be the sum of pressure of water and pressure of ice. So we need to calculate both of them. So first of all, pressure of ice, that is equal to force per unit area. Now we don't have force, but we can get it. Why? Because force of the ice on the, it will be equal to the weight of the ice. So force is equal to weight over area to get pressure of the ice. So mass of the ice is given, which is 690 times value of G, only 9.8, no other option, over area, that is given 5. So as we will simplify it, 690 times 9.8, it is equal to 6762, and then divided by 5, answer is 1352.4, 1352.4, and unit of pressure is pascals. Then my dear friends, pressure of water, that is a fluid, so rho GH, density is given, that is 1000, so it means it is fresh water. G again 9.8 times depth, this is 0.45. So 1000 times 9.8 times 0.45, answer comes to be 4410 pascals. 4410 pascal. This is not the answer. Still we need to calculate the total pressure at X. So pressure at X will be equal to pressure due to ice plus pressure due to water, plus pressure due to water. So now we will place both of these values. So 1352.4 plus 4410 plus 1352.4, answer is 5762.4 pascals. But we cannot write this much long number of significant figures, so we can make it 5.7 times 10 raised to power 123, and unit of pressure is pascal. Even this can be rounded off to 5800 pascals. That will also be correct. If you want to round it off to the nearest 100, so then it can also be written as 5800 pascals. Yes, my dear friends, if there is any question, please feel free. You can ask me now. Okay. Then next is question number 4 of the same paper. The temperature, it is from thermal physics. The temperature of a fixed mass of a gas at constant volume is decreased. Now see, here is needing, it requires to understand it very well. Temperature is decreased, volume is constant, and mass of the gas is also constant. Fixed mass of gas at constant volume is decreased. State and explain in terms of particle how the pressure of the gas changes. Of course, pressure of the gas decreases. Pressure of the gas what? Decreases. Pressure of the gas decreases. So now see here, pressure of gas decreases as kinetic energy of particles decreases. Kinetic energy of particles decreases. Now when the kinetic energy decreases, so it means less number of collisions, less number of collisions of gas particles, and so less force is exerted. Less force is exerted, and less pressure we have already told up, so that is enough. Less force is exerted, and this way we can do it, no worries. Next is state the value of absolute zero in degrees Celsius. Value of absolute zero, that is simply a recall memory, minus 273 degrees Celsius. Explain what is meant by term absolute zero. Refer to the particles in your answer. So absolute zero, it is the lowest possible temperature. Lowest possible, it is the lowest temperature, possible temperature, and kinetic energy of particles is almost zero. It is also a recall memory, we know this, just right to the point. Then my dear friends, cylinder 1 contains 350 centimeter cube of gas. So this is volume 1. At a pressure of this is P1. The gas is transferred to then cylinder 2, and the pressure is increased to this. So this is P2. That's why I was using P1 and V1 in the beginning. The temperature remains constant. It means the Boyle's law in action right now. Calculate the volume of the cylinder 2. So simply P1 V1 is equal to P2 V2. So make V2 as the subject of equation. So P1 V1 over P2. So V2 is equal to 9 times 10 raised to power 4 times V1 is 350 over P2, that is increased pressure, 1.6 times 10 raised to power 5. As you will simplify, answer is going to come 197. So either here you can write 197 centimeter cube or round it off to 200 centimeter cube. In both the ways it's okay. Please my dear friends, if there is any question or query, feel free, you can ask me without any hesitation. Okay, stay blessed.